Okay, so let's go back to our original screen. Okay, so y equals, go here, I want you guys to just follow sine x, okay? And the first thing we have to do is play with our window. So if we go to our window, okay, there's just some random settings here, okay? But let's say if we want to go from 0 to 2 pi, okay? Actually, before this, what should I check?
Radians.
Okay, now it should work in either way, but we have to be smart here. So it's in radians, okay? So we'll keep it like that. But that means this needs to be in radians as well.
Wait, how do you get to the radian screen?
Mode,
Mode.
okay? So yeah, let's all do radians together, okay? Window, okay, so we want this to go from 0 to 2 pi. So all you have to do is 0. In your x max, what do you think I should put here?
2 pi.
Yes, okay? And you can actually literally just enter that, okay? And it'll figure it out for you. So if you hit enter, it's actually going to do the math for you. Okay, now think about this. This is a normal sine curve. Then what's the max and min value?
1 and 1.
Negative 1 and 1, right? So the y minimum is negative 1, and the max is 1. Now you could go a little over to give yourself some room, okay? So that it's not at the very top. So you can see, like, give yourself a little space. You know what I mean?
Oh, wait, 1.
Okay, it's 1 to negative 1, but this one just like, the image will fit in the screen better. Like you can put negative 3 if you want, but, okay? Now hit graph, actually, let me look at this. I don't know if this will matter right now, but let me see.
Oh, it's an error? It's beautiful.
Okay. Are you guys getting that?
Yeah. No.
Can you
Yes.
I'm getting like
Can you help
a really skinny version of that.
Okay, so if you're getting a really skinny version, let's first of all make sure your window is right. Right? So 0 to 2 pi and negative 1 to 1. Is it like that? Is yours?
Wait, so
I
this is
think
the
the y
sine.
minimum is wrong.
Okay. Yes?
This is the sine
What
curve.
Rhea, what animator is that by the same should put it in the Y scale?
It still doesn't work. It's just that.
Okay.
But why isn't the point of going to the little, like, you know, the curve when it
I got
stops into the x-axis?
It's the y minimum.
The middle, like the middle of the middle. Yeah, that point.
Oh, why? Oh, it is there. This is my cursor.
Yeah, but why isn't it the curve touching the bar?
I don't know what you mean. Why is the curve not touching? What bar?
Noise.
Mr. Sahib.
Why is this not going here?
Oh,
And
okay. I'll answer that. Okay. So he's essentially asking, why is this not going through here? First of all, this is defined as, this is 1, this is 2, 3, 4, 5, 6. Okay, but that's pi. So sine of pi equals 0. So this right here is 3.1415, whatever, right? And this here is 2 pi.
Yeah, okay.
So we should be expecting that the period is 2 pi, it's not 2.
So when we grab that
I mean
by
6.
hand,
The period is 2 pi, not 6.
so when we grab that by hand, we need to make sure that
Well, by hand, you just have to label this as pi. Okay, so this is a good something actually all of you need to think about. When you graph it, you don't need to include 1, 2, 3, 4, 5, 6. What you need to include is what's important for this, and that's that this is pi, and that's 2 pi, and that this is pi over 2, and this is 3 pi over 2. Okay? But you don't need to use 1, 2, 3, 4, 5, 6 as a scale. Okay? Actually, I'm happy you asked that question because it makes sense, a lot of sense here. I'm sure a lot of you aren't sure. Okay, if you go to trace, right, and just hit 0, it lets x equals 0, then hit enter, and it gives you your point 0, 0. Make sense? Now if I hit trace and I'm like, oh, what does pi over 2 equal? So you can do pi over 2. Okay, that's 90 degrees, or pi over 2 radians. Enter, it's 1. Right? But you see how this can now help using this? Yes?
What does the little triangle X equals mean?
Delta x. Okay, so if you go to a table of values, go to second graph, the delta x before means how often is this changing. Okay, so where did you see that again?
It was on window because hers
Okay.
is different than mine was with us and so.
Okay, so this here, delta x is 0.023. Let me go back to here. What does most of yours say? Delta 1, like is it 1?
No, mine is 0.668. Hers was yours, but that's the only difference.
Oh my god.
It shouldn't mess up this though.
My is my table card
Let me see for a second. Like it's telling you your maximum is less than your minimum. It's telling you this. So just follow it. So yeah, your y min and y max are both negative. One has to be larger.
And then also, so then why would it change? Why would this change? Mine is 0.66. It still works.
Yeah, it should still work. That doesn't affect this. That affects the table of values. Okay, so
So we can change it.
I forget. Press plus for delta table plus. So in here is 0.5. In the window, let me just think about this. I'm actually not 100% sure what this is. I think this is showing you how many points. So like it's showing you point every 0.02, but I'm not sure. I don't think it won't matter. Is what I'm saying. I think. I think it needs to be small, but actually I'm not 100% sure. But to be honest. Okay. Anyways, yes, let's look at this. Okay. Maya, you alright?
I found out that there's a table on the calculator.
Yes. The table of values.
Yes.
Okay. So if you go to second graph, it gets you to table, and here's your table of values. Okay.
You create one.
You could, okay, one thing that's important here is that you can't create your own, but what you could do is you see this on press plus for delta table. This means how often it's going to change. So this says it's changing every 0.5. Maybe we want it to change every 1 instead.
Mine's always changing.
Wait, how do you do that? Where's
Plus.
Can you input a value for
Okay, now look at this. What do you think is what do you think would be a good value to try putting here?
Every
pi?
Pi, or something related to pi, right? Because we're in radians, right? Let's do pi divided by 2, so every 90, and see if this makes sense.
Oh, that makes
Okay?
Oh my goodness. Oh yeah.
Because this is pi 90, which is 1. This is pi 180, which is 0. Pi 270, which is negative 1. Pi 260, which is 0. Now this, don't get confused by this. This is saying 3 times 10 to the negative 13, which is really like 0.000000. It's just trying to say 0.
Wait, my values don't look like yours.
Yes, they do every pi.
Yeah,
This is
I did every
the
pi.
same as yours. Yeah.
So once again, you came here and you did pi over 2.
Yeah, you do
Yeah,
plus
mine's 0.
second pi divided by 2. That.
Yeah, mine are the same either.
Doesn't make sense though.
Why? Oh my god.
1 second. What you need to realize is that go to second here, table set. Where your table starts is critically important. So let's start it at 0 to keep it all consistent. And then this is another way to get to like here you can just put pi over 2 again. Pi over 2. Okay, that means once again your table is going to start at 0 and then it's going to go up by pi over 2. So now if you go to your table values, it should look like this.
Oh yeah, it does.
Whoa.
Yeah. Oh, wait.
Okay. Is that good?
Wait, so it's pi over 2.
Okay.
I hope that makes it. Okay.
Now they're not to the.
All right.
What's up with that 12.566?
Okay, so once again, this means negative 2 times 10 to the negative 13, okay? So negative 2. Your calculator has limitations, what you need to realize. So if you see something like that, it's trying to tell you 0.000 negative, 0.000, like 13 times in the 2, right? Or 12 times in the 2. Which obviously means it's just trying to say 0, but your calculator has a short.
Why is it randomly double? Yeah, 0, 1, 0, negative 1.
No, it's
0.
meant to be a 0. It's, what I'm saying is your calculator has limitations.
No. I think it's.
Okay.
Okay? Like if I scroll down here, it should probably continue getting messed up, I would assume.
Yeah, it gets more.
Yeah, it's getting more and more messed up. What that means, it's an interesting question here, is how accurately can your calculator do this? Right? And your calculator, no matter what, is starting to round somewhere. So as the calculator is using approximated values, it's getting worse and worse and worse. Think about you have a long question to do with 1 million parts. If you start rounding in step 1, it's going to mess up big time by the time you get to the end. That's what's essentially kind of what's happening here.
That's like an extended essay.
That was like, yeah, that was like his. Okay, so go back to here. You can trace anything, but does that make sense how to get it? Okay, something else that I need to make sure you guys understand is this. Let's quit this. Let's say the question is, actually no, before that, we're going to change this mode to degree. Okay. Now let's go to graph and see what happens. Why is this happening?
Because,
Yeah.
because
It gets to the
It's still the same thing. It's just
golden value.
You're just seeing.
you're just seeing the way beginning because it's instead of being because like okay, imagine if it were in radians, then it'd be 3.14, which would be the third little line.
Yeah.
Would be like would be pi, which is already 180. But here it's in an actual just normal scale, so
Yes.
to get to 180 you have to do
So
all.
this here means 1 degree, 2 degrees, 3 degrees, 4 degrees, 5 degrees, 6 degrees. So you need to change the window so that it becomes what? 360 degrees. How do I change y?
you don't need to.
You don't need to. Very good. I'm trying to throw you off. You do not need to change y. It still goes from 1 to -1. So if you graph this,
Oh, it still works.
it should be the same thing.
Wait, so how is it both -1?
Yeah, but there's two. There's
Okay, you have to remember,
Oh.
sine 30 and sine pi over 6 is 1/2. Nothing's changed there. It's like just a unit of measure, like the radian versus degree. But the ratio is the same. Yes.
So there's two bars.
Yes, what does this mean, everyone?
One.
-1 and?
No.
One.
No, it's because on the
Yeah.
x-axis it looks thicker. It's not 2 bars. It's just
Yeah,
that.
it's 2 bars.
No, it looks like it looked up, but it's not like that there are 2 x-axes. Like look,
Okay.
it's not.
It's
because
of the y.
Got it.
X scale.
You're saying this is just thicker.
Yeah, it looks like
Okay. Anyways, okay, that's that. Now let me ask you, so you need to make sure you understand that. If I do sine x equals 1/2, what is x? Okay, just as a review, you should realize this from right angles anyway. You just do this, sine, like 0.5, 30 degrees, right? Okay, but okay, this is the acute. The calculator gives you the acute angle, less than 90 degrees. Okay, like in this example. Yes, you can. There's many answers to this. Technically, this 150 degrees also works,
210.
but 30 not for positive. 30 plus 360, 390 degrees will also work, but it's only going to give you the one main case. But obviously, these are going to repeat over and over and over again. Okay. Now let's change it to radian. Okay, let's do the same thing now. Okay, so second sine 0.5. What do you guys think is going to come here?
Pi value.
Pi over 6. Now your calculator can't do pi, which is where you are going. Although I'm going to give you calculators for your test, this now forces you to understand like pi over 6 and all that kind of stuff. Okay, however, you can get that easily because remember 30 degrees. How do you change that to a radian? You multiply it by pi over 180, which will reduce to this.
But so why does it give you pi over 6 and not 5 pi over 6?
Okay, because it's going to give you the acute angle, meaning the one less than 90. They can only give you one. Sorry?
How'd you get 30?
Because sine 1/2.
Because
I know, but like how doesn't it not normally give you 30? Doesn't it give you 0.5?
oh, this is the same thing. This is the first one is degrees.
Yeah, no. Okay.
That's right.
Wasn't degrees.
Yes. Yeah.
So the value of square root of 3 over 2 is equal to the y value when x is 60 if you have if you don't change it from pi to 360